Hi, IB biology students. So, turns out we have a snow day tomorrow. I'm sorry I had to give you additional homework to do in addition to your IA, but we're really at crunch time for the IB exam since those days are going to be made up after the IB exam. So, here it is, some additional work for you to do over break. Basically, what I want you to do is finish that lab packet that I gave you on the isopods so that we can come in on Tuesday. I'm pretty sure we're going to have to school on Tuesday. It shouldn't be that bad. And we'll spend like 10 minutes maximum talking about the things the isopods liked or didn't like, answering your questions about chi-square, and then we'll move on to SL, studying for your midterm, HL, learning a little bit more animal behavior stuff. That being said, if we don't have school on Tuesday, I'll send out another email, but your homework is what is online. HL, I might give you some more resources to use, but SL, your homework is just to study for that midterm exam that you're going to have on Friday. So just a quick reminder, at the end of your lab packet, I attached the DCP CE grading rubric. So if you're saying to yourself, oh my god, Miss Dempsey, I have no idea what to do for my DCP or CE, well, there's the grading rubric. I also put, just FYI, the grading rubric on Dropbox for you so that you can use it for your reaction time IA, which having a whole day off tomorrow means you can just force your family members and friends to do experiments with you. Maybe you can cross-country ski over to another IB biology student's house, do an experiment there, whatever it takes, but you definitely need to have your design 100% done and your DCP started at this point for your IA. Anyway, moving on to isopods. So, some of this is going to be reviewed from what we talked about already in class, but I know it's been a few days, so let's go back to what you did. You did an experiment, and you had these little tiny creatures, and they either went to one side of the container, maybe to someone used food, or no food. So, some of the isopods went to the food, and then some of the isopods went to the no food. You took data of how many were in each spot every 30 seconds or minute, depending on the group. So what you need to do in order to do your chi-square test is take the average of all the isopods in one conditioned and then the average of all the isopods in the other conditioned. For example, if you were doing the experiment that the other science teacher showed you with wet and dry, you would take all of the values for wet that you had, including the initial one, including that 4 or 3, depending on how many you had on each side, what you got at 30 seconds, what you got at a minute, what you got at a minute 30 seconds, 2 minutes, etc., etc. Take all those numbers that you had, that you saw throughout, and add them up. You're not doing, well, where were they at the end? It doesn't matter where they were at the end. It matters how many were on each side at each time. It's not like 5 minutes was the do or die time where the isopods decided their fate, their life, of what they liked better. So you're adding up all of the data points for, in this example, wet, all the data points for dry, average them, and those are your observed values, which we're going to need for chi-squared. Your expected are however many you had at each side in the beginning. So maybe you had 6 total isopods, you put 3 on each side. If so, then your expected is 3 and 3, right? Because you would expect, if there was no preference, when you averaged all the data, that half of them would be on one side and half of them would be on the other side. In this example, there was 5 and 5, but depends on how many you had on each side. That's your expected. You may also want to do a standard deviation if you're feeling adventurous. So this is the chi-square test. So once again, just to review with you, the observed is what you got for each condition. So that big summation sign, that big E at the front, means sum them up. So you're going to do O minus E squared over E for wet plus O minus E squared over E for dry. And that added together is going to be chi-squared. Observed is what you got in the experiment. Expected is half and half. You expected half on one side, half on the other side. Oh, funny story. I was correct the first time about the math. Those of you that were saying number of sample subjects minus 2 were thinking about the t-test. over the weekend I was thinking more about it and thinking that I was right, and I looked it up, and I was. So, your degrees of freedom is the number of variations of the independent variable minus 1, as I initially said. So please, please, please change that. I'm sorry that I told you the wrong thing. What does that mean? How many different variations did you have? Well, you had 2, right? There were 2 sides of the twist chamber. So, every single one of you, no matter what experiment you did, your degrees of freedom is going to be 1. Also, when I was giving you that information about the t-test incorrectly, I gave you the wrong chart. So, once again, I apologize. We can talk more about the difference between t-test and chi-squared on Tuesday, but what I want you to notice is that your degrees of freedom for every single one of you is going to be, or your critical value, is going to be 3.84, because you have 1 degree of freedom and your probability is 0.05. So every single one of you is using 3.84, no matter how many sample size you have, how many data points. So once again, to review, if chi-squared is greater than the critical value, aka 3.84, that number from the table, you reject your null hypothesis. Well, what did your null hypothesis say? It said that your null hypothesis says no. No means no. So there is no significant difference between wet and dry. So you're going to reject this. You're going to say it's wrong. So what does that mean? Well, that means there is a significant difference between your conditions. I think for most of you did find there was a significant difference, which means you designed great experiments and you found something they really liked and they really didn't like, which is awesome. So once again, chi-squared greater than critical value, which is 3.84, reject it. There is a significant difference. Most of you are probably going to find that. If it's chi-squared is less than 3.84, you accept the null hypothesis. There is no significant difference. Then, once you do lots of math, you're going to do your C and E. Write a conclusion. Don't write out paragraphs for me. The goal is to help you practice this information. It's not for you to write me a novel about your conclusion. So, important things I want you to address. Use the rubric, but was there a significant difference between your data? What qualitative data did you observe? I was walking around and heard some very interesting stories about this one was really, really excited. This one just kept hiding. This one was running around in circles and just had ADD. So, whatever qualitative data you can contribute, write that down too. Scientific explanation for this. Well, a lot of you are going to be like, well, pill bugs normally live in wood. So guess what? They liked wood. Duh. So that's fine. That can be your scientific explanation. What errors were there in the experiment? Did you have one pill bug that you accidentally killed? Did one pill bug just ride around the other pill bug's back piggyback style? Did that negatively affect your experiment? Whatever it is. Improvements. I know all of you could write one easy improvement related to IB, related to sample size. Wouldn't it be better to do this 5 times? And some of you are actually asking me about that. Anything else you think to improve? Keep in mind that this is a great, great, great practice for your IA that is due next week. Then, the IB standards that are related to this. One of them was design an experiment from invertebrate behavior. You did that. Hooray. Done. The other IB standard is analyzing data from it in terms of the effect on chances of survival and reproduction. We've seen this again and again and again. We've seen this with other innate behaviors. We've talked about the black-capped sparrows and how they migrated to different places and then they got back earlier, so all the ladies liked them and they had more babies. So that's what standard you're going to keep in mind for this. How does this data support the idea of this invertebrate, this pill bug's innate behavior that improves its survival and reproduction? So you're thinking about something like, well, if the pill bug likes to live in wood, for example, that would make sense because pill bugs generally live in the forest. It doesn't have to be super complicated, but you do definitely need to fill out this page and definitely need to reference specifically how would their survival be improved, and then as a result, how would their reproduction be improved. This is a great time to practice that IB standard that's in the core material on explain evolution in terms of how it improves survival and reproduction, the one that always asks you about antibiotic resistance. So please write that up, how it would improve their survival and reproduction. Reference that evolution question if you need to. So that is all I would like you to do for your homework. Please, please, please also work on your IAs. I really want to see good grades out of you. You all are very, very capable at this point in writing an awesome IA. So spend some time working on that as well, so that way you're not stressed out all during the week, or you don't have to spend, maybe next weekend will magically be warmer. I doubt it, but who knows. So please spend time working on your IAs if you haven't already, if you haven't put in the time. Also, if you can please pass this word along to your friends. I'm going to send out an email via Turnitin tonight and put this video on YouTube, but I know some of you check your email all the time and some of you don't really check it. So please, please post this on the Facebook page, Snapchat it, whatever you got to do so that people know what the expectation is for tomorrow. Additionally, if you need anything from me, I will check my regular email. I don't check my school email, but I'll check my personal email tomorrow morning for you all, and then I'll check it at some point during the day. But I don't have a smartphone, so I'm not going to be checking all day. So if you do have any questions, concerns, anything comes up, you can feel free to email me. Once again, I'm sorry I had to give you homework in addition to your IA, because I know that's a lot, but we really are at crunch time. So have a great snow day, and I hope to see you all on Tuesday.